So this is a HSC question that is from year 11 that could be, that could be in your trial. Okay, so there's 36 numbers or 37 numbers. And so this wheel just has numbers 1 to 37 on it. 1, 0 to 37. So just have them each once. And so we know that we have a 1 in 37 chance. I'll explain in a second. Let me just check. Yeah. Equals 500. Okay. Let me explain this. Okay, are you ready?
Yeah.
Okay, cool. So a wheel has numbers 0 to 36. So 37 numbers all up. And they're each equally likely to be spun. So if they're each likely to be spun, they're all in the even, like they're all either twice occurring or they're either 3 times occurring, but they're all occurring at the same amount. Does that make sense?
Right.
Because they're all equally likely to spawn. Like if the number 21 appeared twice and the number 18 appeared 3 times and then the number 7 appeared once, that's like not equally likely to be spun because 18 is more likely than 7. Does that make sense?
Yeah.
Okay, cool. And so if they're all equally likely to be spun, that means this wheel just has numbers 0 to 37 and they all are just occurring once. Is that cool?
Yes.
And like if you were to count all the numbers, they would just be like there once. So there's 1. Anyway, cool with that?
Yeah.
Okay, and it says calculate the expected frequency of spinning the number 8 if the wheel is spun 18,500 times. And so 8 is only one number on here, one number out of 37. And so you just have to figure out what one number out of 37 times would be like likely. And it equals 500.
Okay.
So if you spun this 18,500 times, you would probably get the number 8 at least 500 times.
Okay. I'm just writing that down.
Yeah, I can write down like there's a formula for it. You don't have to remember it if you like understand the principles, but it's expected frequency. Oops. N times P equals NP. Wait, ignore that. I don't like that equation. I'm going to make up my own one. Maybe. Does this part here make sense to you?
Yeah.
Okay, cool. Because 8's only one number on here and there's 37 numbers. And so 1/37 of 18,500. So that's expected frequency. The only other one is relative frequency. Wherever that is. I can't find it here. Here it is. But I don't have a question on it. Okay. Let's have a look. So did you decide on, how do I stop share? What topic did you decide on doing? I'll type up.
Do you want to do, I don't know. Are you sure I'm fine with applications of measurement?
We can go over it again if you want.
It's like, I feel like it's either formula and equations, linear relationships.
Do you want to just go over like everything in year 11?
Yeah, do you want to just go like over everything for the preliminary?
Yeah. Let me just find a PowerPoint because the computer's gonna die.
Okay.
Okay, there it is. Hang on. Okay. Okay. Now let me find the year 11 textbook. I just had it before. Yeah. Okay. What one did we want to do? Let me see. Formula.
Can we start with? Yeah.
Okay. No. Okay. Here. So the first part in that one, in formula and equations, is subbing. And so I feel like you'd be pretty good with this one.
Okay.
Have a go at it and let me know when you've done it.
Okay. Do I put it in brackets?
Yeah.
Or do I times it?
So it'd be Is that what you meant by brackets?
Yeah.
Cool.
Okay, do I just figure that out?
You can just pop it into your calculator.
Yeah. Did you get negative 24?
Yeah. So that's all substitution is. It's just when they give you values and you literally just sub them in.
Okay.
Let's have a look at the next one. distance, speed, and time. We can just do like, are you cool with distance? Oh, we'll do this one. Okay.
Yeah, I feel like wasn't it like not too hard?
Yeah, it shouldn't be at all. If we just do like one question, we should be able to get through like pretty much all of it.
Yeah.
Okay.
Sorry, I'm just writing a question down.
That's all good. Just let me know when you have an answer.
Yeah.
And we can go.
Do you get 325?
Mm-hmm.
And then I work out B.
Yeah.
Um, 2.5 hours.
Mm-hmm. Yeah.
Okay.
Okay, let's have a look at the next one. Linear equation. Okay. So you just have to find what x equals.
Find what equals?
X.
Okay.
So yeah. Um, Okay. Oops.
You get -10?
No, I didn't. What did you do?
I feel like it did. Did I what, sorry?
What did you do first?
Well, I moved the +5 to the other side.
So -2 minus 5?
Yeah, and then I got -7.
Mm-hmm.
And then I moved the 3 to the other side. But am I meant to divide it?
Yeah. Because that's like a times there. So then x equals -7 on 3.
Okay.
Yeah.
So, okay.
Which equals, I don't know what it equals.
In my -2.3.
Yeah. 2.3 repeater. Cool. Let's have a look. How do I? There. Let's do this one.
Okay. Is this still for linear equations?
Yeah. So we're still in formula and equations. So do you know how to do this one? You have to get the bases to be the same.
Right.
And so say this was over 1. And so you just got to think like what's a number that 3 and 7 can both go into. And so I think the closest one is 21. And so we've got to change this to 21 by timesing by 7. And whatever you do to the bottom, you have to do to the top. So we'll do y times 7 over 3 times 7. And then y times 3 over 7 times 3. 2 times 21 over 1 times 21. And then, so that's 7y over 21 minus 3y over 21 equals 42. And then when they're both to the same like denominator, you can then, I'll just go down. I don't have enough room. You can then just like forget about the fraction. And so then it's just 7y minus 3y equals 42. So then that's 4y equals 42. And then y equals 10.5.
What did you do with the 2 times 21? Oh, wait.
Because when you're changing fractions, that's like as if it was over 1 and you have to like times everything to get everything the same denominator.
Yeah.
And so then you have to times it by 21. And whatever you do to the bottom, you have to do to the top. So you times that by 3 times the bottom. Does that make sense? Does this step here make sense?
Yeah, what does the 4y mean?
4y here.
Yeah.
I had just went 7y minus 3y. And then I got 4y equals 42. And then I just divided 42 by 4 to get y equals 10.5. Fractions get the same denominator, and what do to the Does that make sense? This what I just wrote there?
Yeah. Should I write it down?
I don't know if it'll be helpful or not.
Yeah, I'll just write it like on the
Cool.
side. Okay.
All right, let's have a look. Why can't I? There we go. Next. No, we know how to do that. Do you know how to change the subject of the formula? Are you all good with that? Like if it says this, make n the subject of the equation. So you have to rearrange it to get n here.
Right.
You want to have a go at this one?
Yeah.
Okay. So they just want you to put n out the front instead of c. So you're essentially getting n by itself.
Okay. Would I move the 40n to the left side?
Well, you can. I wouldn't because you want it. I mean, you want to get n by itself. And so I'd probably like take the 75 over first. Does that, like,
Okay.
you can do it, but then you'll just have to take the 40 back over. Because you could do like c minus 40n equals 75. And then you just have to like start to get rid of these two, the c and the 40, to get n by itself. Does that make sense? So it's better off like, then you're just like making more work for yourself. I feel like it'd be easier just to go c minus 75 equals 40n. Does that make sense?
Yeah. So does it matter if it's all on the left side and then ends on the right side by itself?
Nah, it doesn't matter which side. Just as long as on one side n is by itself. Whether
Okay.
n equals or equals n, it doesn't matter.
So C minus 75 equals 40n.
Mm-hmm.
And then would I go C equals 75 minus 40?
Divide. N and 40, that's a times in there. And so to get the 40 like away from the n, you have to do the opposite. So we divide. Does that make sense?
Okay.
And then n's just chilling there by itself out the front or out the back, whatever. Does it make sense, that step?
Yeah.
Steps? Yeah?
Yeah, it just makes me to think of it like before I.
Okay. Right. All good with that one?
Yeah.
Okay. Blood alcohol concentration. This is where,
That's fine, isn't it?
yeah, they just give you the formula and you just substitute them in. And we've
Yeah.
already done substitution, so I think we can just skip over that one.
Yeah.
But you don't have to like worry about memorizing the formula because they have to give it to you.
Okay.
And the same for like this medication thing. They will tell you what rule to use. There's like younger parts pretty much, these ones.
Yeah.
They'll tell you the rule and you just have to substitute it in.
Okay.
And so a 3-year-old child, if the adult dose is 50, you put the dose there. I mean, adult dose there, 50, and year is Y. So then it just looks like that. 3 times 50
Okay.
3 plus 12. So you just substitute it in. So we're fine with that.
Okay.
Okay, that's formula and equations done. What's the next chapter you want to, do you want to linear relationships or applications of measurement or data?
Yeah, do you want to like quickly like do applications of measurements?
Mm-hmm. Okay, let me find it. That's just going to take me back. Okay. Okay. I don't think we have to worry about doing this part. This is just like the conversions. So like.
Right. Oh wait, can I screen that?
Mm-hmm.
Okay.
So 1,000 grams is 1 kilogram. Did you screenshot it?
Yeah.
Do you want to screenshot this one? I don't know if that part's helpful or not.
Yeah. Okay.
Cool. Yeah. This is the what is it called? Absolute error that we looked at last lesson.
Oh.
Do you want to do a question on it or just skip past it?
Is it in my exam?
It might be, it might not be. If it is, it'll be like worth like 2 marks or something. But it could be.
Okay, might as well just do it.
Okay. Yeah. We just need to know those. Wait, let me do it like. Dang it. Oh well. Okay, never mind. And do you remember precision? I still can't say that word, but it's just the absolute error, which is half the smallest unit of measurement. I think that is on your reference sheet though.
Okay.
Yeah. And so on a centimeter ruler, what's the smallest unit of measurement?
You mean like millimeters or something?
Yeah, millimeters. And so if it's 1 millimeter, what's half of 1 millimeter?
0.5?
Yeah. 0.5 millimeters. Yeah. So even though it's like a centimeter ruler, the half of the smallest unit of measurement is 0.5 millimeters. What is the upper and lower bound for each measurement? Okay, this is up here. Measurement plus absolute error, measurement minus absolute error. Okay. So upper, again, I've forgotten already. I don't think the upper and lower bound, it is on your reference sheet, but I don't think I've ever done a question on it. I've just done the precision part. Let me see what it is. Oh, that's right. Measurement plus absolute error, measurement minus absolute error. So I'll just show you the answers for this one so we can have a look at some different questions. But the length on this one is 38, obviously.
Yeah.
The precision which we found was 0.5 millimeters. And so then lower bound is measurement minus, upper bound measurement plus.
Wait, so when it says what is the precision, was that 0.5 millimeters?
Yeah, so that's just half the smallest. So if you're taking notes, just say on a centimeter ruler, the precision would be half the smallest unit of measurement. And half of 1 millimeter equals 0.5. Does that make sense what I just typed out? On a centimeter ruler, the precision will be half the smallest unit of measurement, and half the smallest unit of measurement, 1 millimeter, equals 0.5 millimeters.
Yeah, and half the.
All good?
Yeah.
Cool. Ah. Okay. Are you all good with scientific notation?
Oh yeah, that stuff's like really easy, isn't it?
Yeah.
Okay.
Food and nutrition. Okay, do you want to do a question in food and nutrition? I mean,
Is that in my exam?
pardon?
Is that in my exam?
It might be a multiple choice one, it might not be. Like,
Okay.
it's hard to tell. But it could be in your exam.
Should I do it?
Like, we can just quickly do it.
Okay.
Maybe, like, don't bother writing it down, I don't think, but
Okay.
this question is really easy, I think.
Well, isn't the answer in the table?
Yeah.
Okay. Well, doesn't it say? It literally all says on the table, right?
But we just
Okay.
need to know which number it would be out of these four.
Oh, both top row.
Yeah, but is Jenny a male or female?
A female?
Yeah, so it'd just be 9,000.
Yeah.
Cool. And then this one might be a little bit harder. Mitchell is 25 years old and works out at the gym for 2 hours. A gym workout uses that much. So how much does he need each day? He's 25. So he would still be in the 12,500 one.
Yeah. That's what I was thinking.
And then he also does an extra gym for 2 hours. So that's
Okay.
plus 2 times 2,500. Because this is how much kilojoules your body requires, and so he needs like an extra, right?
Okay.
And so, because like a normal person would use that much without going to the gym. That's just like daily activities. So when you go to the gym, you use extra. You need extra. So I can't be bothered to calculate with my calculator what it would equal, but that's what it would equal. That's what we did, right? 2 times 2,500 plus that. Yeah. So that's pretty easy. Food labels is just reading off it says what is the serving size. You just go to where it says serving size, 30 grams, like easy. So I think you're good with that.
Yeah.
Energy consumption. Are you all good with? We've done this one before, but
Yeah.
do you want to do just one question on it, or do you just want to skip over it?
Was that topic easy? I feel like it was easy, wasn't
I
it?
think you were good at it, yeah. We can just do like A if you want, just question example 8A. Actually, let's do B.
Okay.
Do you want to do it and then tell me what you got?
Yeah.
You don't have to write it down, I don't think. I mean,
Is it 2.4 times 17 cents? And that times 5?
Yeah.
So 2.04?
Yeah.
Okay, cool.
Cool. Okay.